Hello everyone, welcome to my YouTube channel. Today we are going to look into trigonometric identities. We'll prove the identities and the other variations which you can do in the formula can also be looked into it. Now here I have taken up the first identity, sin square a plus cos square a is equal to 1. Now to prove this we require a right angle triangle. I have taken up n triangle ABC, angle B is equal to 90 degrees and angle A is going to be acute. Now according to Pythagoras theorem, AC square is equal to AB square plus BC square. Hypotenuse square is equal to sum of the squares of the other two sides. Now if you take up LHS is sin square A plus cos square A. Now if we go into trigonometric functions, sin is going to be opposite side divided by hypotenuse. That means here it is BC divided by AC and whole square it is. Cos square A or cos A, cos is going to be adjacent by hypotenuse, that is adjacent is AB and hypotenuse is going to be AC and it has got a square, so whole square it is. Now if you square it up, it is BC square divided by AC square plus AB square divided by AC square. Now we have got a common LCM here. LCM is AC square. So if it is common LCM, then we take it as BC square plus AB square in the numerator. Now if you look into the first equation, it says AC square is equal to AB square plus BC square, or it is BC square plus AB square. Now from equation 1, the whole of this value is going to be AC square divided by AC square. Bracket we write it as from equation 1. So AC square and AC square gets cancelled. The result is going to be equal to 1. Therefore, LHS is equal to RHS. Now this is the first identity. Sin square A plus cos square A value is equal to 1. Now what all the manipulations you can do in this particular formula. Now here, according to the formula, it says sin square A plus cos square A is equal to 1, the identity. Now if you want to apply for sin square A, then sin square A is going to be equal to, if I shift this, it is going to be 1 minus cos square A. Now further, if you have to split this, it is understood, 1 means it is understood as 1 square. So you can also write this as 1 plus cos A into 1 minus cos A. That means it is understood it is in the form of A square minus B square, which is equal to A plus B into A minus B. 1 square is going to be 1 only. Similarly, if I look into the next part, if I keep it as cos square A is going to be equal to 1 minus sin square A. According to the requirement of the problem, you are going to apply it. Further, it can also be written as 1 plus sin A into 1 minus sin A. That is A plus B into A minus B. Now it depends on the problem how you are going to apply this value and how you are going to apply this value. In certain situation, problem is going to get solved in this particular level itself, or further you have to go up to these particular levels. So this is the different manipulations which you can do from sin square A plus cos square A, which is equal to 1 it is. Now we are going to look into the next identity, the second one, for which we don't require particularly the right angle triangle. I just leave it over there. I look into the next one, the second identity. It says 1 plus tan square A is equal to secant square A. The second one. Now we don't require a triangle, we just go into reciprocal ratios. Now if you look into LHS, 1 plus tan square A, which I required to prove it as secant square A. Now I keep this 1 as it is, tan theta or tan A according to reciprocal ratios can be written as equal to sin A divided by cos A. Now according to that, if I apply it over here, then it is going to be sin A divided by cos A, and I've got a square there, whole square it is going to be. Now further 1 plus, applying the square for them, sin square a divided by cos square a it is. Now we are going to LCM. LCM of this is cos square a. So LCM has to be multiplied to each and every term. 1 into cos square a is going to be equal to cos square a, plus when I multiply here, cos square a gets cancelled, left out is going to be sin square a. Now this comes to the first identity which we learned, cos square a plus sin square a, or sin square a plus cos square a, value is going to be equal to 1. So further it is going to be 1 by cos square a. Now in reciprocal ratios, we have learned that 1 by cos a, reciprocal of cos is going to be sec or secant a it is. So I reciprocal this, when you reciprocal it, it is going to be equal to secant square a. So therefore we can say LHS is equal to RHS. So we have used the reciprocal ratios in two places. One for tan is going to be sin by cos, square it, LCM, and then apply the first identity value, then reciprocal again, you get it as secant square a it is going to be. So now the manipulations in the identity, what all you can do in the problems. So if you look into 1 plus tan square a, the changes which you can do here, for example, if I shift this plus 1 over here, that means it becomes secant square a minus 1, which is going to be equal to tan square a. Or as it implies, if you shift this tan square a other side, then secant square a minus tan square a value is going to be equal to 1. Now it depends on different problems how you are going to apply it, but basic understanding is 1 plus tan square a is equal to secant square a it is going to be. Now the next identity, the third one, which is going to be 1 plus, we have to prove that 1 plus cot square a is equal to cosecant square a. This also we require reciprocal ratios. I will take up LHS. LHS is 1 plus cot square a. Now as we learned in reciprocal ratios, cot a is going to be equal to cos a divided by sin a it is going to be. Now further I apply that as we did in the previous identity. In place of cot a, I can write it as cos a divided by sin a whole square it is. So 1 plus, apply that square root, cos square a divided by sin square a. Further we take LCM. LCM is going to be sin square a. So multiply this, 1 into sin square a is going to be sin square a plus cos square a. Now the numerator comes to the first identity, sin square a plus cos square a, value is going to be 1 divided by sin square a. Now it goes back to the reciprocals. We know that 1 by sin a is going to be equal to cosecant a, or sin a is going to be equal to 1 by cosec a. So 1 by sin square a is going to be equal to cosecant square a. This is going to be the RHS part. Therefore, we can say LHS is equal to RHS. Both of them had the same thing. Only difference was that sin and cos. Tan was sin by cos. Here cot was cos by sin. Then the normal procedure, take LCM, go back to the first identity, apply the identity value, reciprocal it, you get it as cosecant square a. Now the manipulations or the changes which you can do to the identity here, depending on the problem what you have got. Now here cot square a can be equal to cosecant square a minus 1, that is shift it as that side, cosecant. Or you should shift this wherever there is cosecant square a minus cot square a, that value is going to be equal to 1. These are your implementations. It depends on the problem how you are going to apply this based on LHS and RHS problem, because these are problems which have to be more practice. Lot of amount of practice is required for this problem, but for 10th standard syllabus it is only these identities and the reciprocal ratios or the functions which you have learned initially. All these will come into picture. Interesting problems, thousands of problems are there. You work out each one of them. It creates a lot of interest in it. But you require that basic part of those three identities, how you're going to manipulate that and how you're going to put it in the problem and prove it from LHS to RHS. Take up some of the interesting problems proving for LHS and RHS. So work on these problems, these identities, know these identities perfectly, and brush up with from the beginning what I've done. That is, I require those initial trigonometric functions which you looked into it, and all those reciprocal ratios, including these identities. It will make much simpler and easier to understand and to implement in the problems. That's all for today's video. Hope to do the next video much earlier because I took a lot of days to do this, the next one, because of the exams and all. Subscribe, share, and this will help me a lot to make the videos. Thank you.